Hello and welcome back to the lab. Today on the bench we have a HP wide range oscillator. This one is of a 200 CD flavor. This is a smaller and more modern variant of the HP 200A, which was the very first product that the Hewlett-Packard company ever made. So in this one, the handle's toast, as per normal with stuff this age. And then I should not be picking it up by the handle because it is toast. Somebody's fitted an NEC plug. I'm not sure if this on the CD version was factory or not. Looks like it could have been. But this is still going to be vacuum tube based. So we got a little bit more tube stuff. But needs a little bit of cleanup. There is definitely some discoloration around this dial face. That could potentially be nicotine, could potentially be something else. But we'll take the dial face off and clean it up. I've also checked. The dial doesn't quite line up with the indication mark, so it needs to be readjusted anyway. When we have the case off, we'll give it a good scrub with soap and water. This one is destined for our bench here, so clean up all the controls, definitely get some contact cleaner in the banana jacks and get them all straightened up, and then do a alignment on the unit. The tuning capacitor that's behind here is tuning very well. We also have this knob that's turning as well, so all in all, it's in great shape. It's in good shape for its age. Does need some TLC, but let's get it cracked open and see what we are running up against. Okay, to get into this unit, these two screws in the back need to come out, and then the whole back will slide off. Well, I am not sure what we are going to find. However, we have two different size screws, and these are Phillips. Normally, things of this vintage are flatheads, so we are not the first people to be in here. Not surprising given the age and the popularity of this unit, but what will we find? All right, here we go. Let's pull this thing off. Come on. No, there we go. Okay, it wants to come out the other way. This thing is awkwardly heavy. Oh. Get that out of the way. Well, we are going to need to do some cleaning. It is a bit dusty, for sure. So, lots of dust. So that'll need to get cleaned up, which won't be fine. Not too much going on around here. EL86s or 6CW5s. What do we have on the other side? We have the 6AU6 design with the two bulbs. So that's working. The switches look kind of dusty and everything, so we are definitely going to want to blow this out. Uh-oh. Yeah, it got whacked. The transformer is sitting at an angle, so it looks like the transformer may have taken a hit at some point in time. Looks like it's been a while, though, because it hasn't disturbed the dust. What do we have? Are these HP tubes, or are these something else? Sylvania's. We will check the tubes on our the one functioning tube tester that we have here in the lab at the moment. We'll hook these up to the Stark. I don't need absolute readings on these tubes. However, matching them and having them be balanced will be important. So the fact that we're doing it both on the Stark is fine. It's just the tubes, everything about this needs to be balanced to get the distortion specs that are in the manual. We have a couple controls over here. I have no idea what that is. What is that? Let's see what that... it's not a tube, but I honestly don't know what that is. This looks in great shape. A little bit of dust, some cobwebs. Definitely need to get some cleaner. Contacts are looking pretty crappy, but that's kind of normal. So we'll get some contact cleaner in there, clean everything up. That won't be a problem. Got a couple of adjustment pots in there. Nothing critical. All in all, very nice design. Okay, are we dealing with multi-section caps? Yes. That never makes it fun. Okay, so we'll get these caps replaced with some modern equivalents. These are power resistors. These are going to be okay. Got some mica caps. Those are all right. I'm kind of worried about these two big black capacitors. I may need to swap those out. Those are 0.5 microfarad at 400 volts DC. But we will definitely want to check them for leakage just to make sure they're okay. Let's see, pot cap coils. Yeah, everything else kind of looks okay. So this one's going to be pretty straightforward. My big concerns are the bulk filters for sure. And that one's going to be fun to work on. Oh, they're both multi-section. This is probably the output transformer. I may end up moving this off the... No, this is a choke because it's in line with the bulk filter cap. This has got to be a choke for power supply cleanup. Yeah, so I have a little bit of work to do. That's okay, though. This unit will be great for restoration. We do look like something got really hot and toasty here. There's burning on the chassis. I wonder what that's from. Comes off on my hands. Let's see if I can show that. Right here, looks like something may have smoked out at some point in time. Or at least gotten very, very warm. Okay, I've got the choke pulled out. I had to actually disconnect the low frequency transformer, which is on the back side of this plate. I've just got it attached in. The other bolts are still open. First cap I'm attacking is C12, which is actually wired kind of strangely. This is one huge choke. You'll notice there's no ground connected, and it's just got two wires going to two sides of the multi-part capacitor. Well, they run off to the resistors over here, and they're hooked up to the bottom side of the resistor. The capacitor is wired up in such a way where it's a 100 microfarad, 100 volt bipolar capacitor. I am probably not going to be able to find much modern equivalent for that, so I'm going to have to make one. So what I got to do is I got to take these two capacitors, tie their ground leads together, and that'll let me make a bipolar cap. Okay, I've got C12 replaced again. This is not going to show up on camera well, but this is a 100 microfarad, 100 volt non-polar capacitor. So this is a non-polarized aluminum electrolytic capacitor. You can make one by putting a capacitor not in traditional series, but by tying the negatives or the positives together on the capacitor. In this case, I tied the negatives together, and then hooking the capacitor up this way on the two bodies of the capacitor. Now this one was not measuring correctly. This was measuring very strangely, so I did replace it. This is also a very common failure point in a 200 series oscillator. And typically when they go, this choke, L6, when this capacitor shorts, it tends to draw heavy current and short out L6. And this is that would be a very hard part to source these days. Also, even if you could source it, because it's such a big inductor, being a choke, that would also not be a cheap part to source. So that's good there. Distortion right now is, the waveform is nice and stable. And distortion right now is running at negative 51.1 dB. The spec on this unit is negative 54 dB. We have not done an adjustment on anything on this unit yet. I'm still getting it ready to go. And I've got even more parts to come in to rebuild the power supply. I was out of terminal tie strips of the appropriate size, so they need to go in. My fingers are nowhere near the unit. I'm about 2 feet away. They need to go in right here to replace that capacitor. And I also want to replace this capacitor right there. So that's still work to do, but I'm going to let it run right now just to make sure we don't have any problems and that bipolar cap holds. If everything goes good there, we'll move on to the rest of the power supply. To get the choke off, you do have to take the output transformer off. So this is choke, power transformers on top, and then this is the output transformer down here. You do have to unbolt the output transformer. I only have it held in with 2 bolts right now because it's going to have to come out for me to reattach that choke again when I get everything done. I am also probably going to replace these capacitors. They are Mylar caps. Not necessarily sure if I need to replace those or not. Distortion's okay. We're about 4 dB off of spec, but the waveform on the scope is nice and stable. As with all the repairs that I do in the lab, I'm not interested in like tuning for the absolute reference to NIST, but I do want all the gear to be within manufacturer specification. So we'll see what happens if we need to work on this cap and that cap. But everything's running well. I do have it on the current limited variac supply. And we are at full line voltage. And actually my distortion went down even further because it was limiting a little bit. It was pulling down to about 110 volts. Now that we're at 124 volts RMS, I have a distortion spec of negative 53.8, which is actually negative 54.2. So just by changing out this cap, we went from out of spec to in spec in terms of distortion and giving it full line voltage. That's my bad. So the unit is performing very well. I expect it to improve even more once we do a adjustment. I'll show you the distortion meter. So we've got the 200C plumbed into the AA501A. My mistake that I made last time, which made me go back to that other capacitor thinking the bipolar cap wasn't working correctly, was I had this plug this way, so it was doing a differential measurement as opposed to a positive and ground measurement. And I have the front end of the 200 CD set up for grounded measurement, not balanced measurement. So this is for balanced, this is for single-ended, and I had the front end set up for single-ended. So if I change this, we just pop this out, put that in there, we catch us back up. Because this is now on the ground side, we can see the distortion specs are infinitely worse. So just something to watch out for when doing distortion measurements. Even though this is tube gear, the output of the 200 is set to about 30%, and even unloaded it only goes to 20 volts. So well within safe handling realm. We weren't putting like 200 volt sine waves into the front end of that distortion meter, even though it can handle it. I have the input monitor set up because I wanted to see the waveform on the scope. So I'll move over to the scope real quick. And this is what comes out of the input monitor. Now this is buffered, so you cannot take a amplitude measurement. It's not an exact
replica of the waveform coming out of the AA501, at least from an amplitude standpoint. From a quality standpoint, it is. So this is showing us what's coming into the AA501, just not at whatever the amplitude is. If I remember the specifications on the AA501 correctly, which I may or may not, so always double check, with a 200 volt sine wave input to the AA501, which it can handle, because it can handle 300 volts peak to peak between plus or minus and plus and ground. With a 200 volt input, you'll have 5 volts of amplitude out the input monitor. So it's a way you can use a scope to kind of use the AA501 as a front end, get a real high amplitude signal that the scope may or may not be able to handle without a probe. Usually they won't handle that without a probe. You'll need some kind of division to bring it down to a safe input for a scope. So it allows you to have a visual as to what it sees. Now the other output on the 501, which is really cool, is the function output is post-notch filter. So it's pretty much whatever the unit sees after it notches out the fundamental frequency. So what's really cool about that, and we'll do that once we get this fully restored, is you can take the function output, throw it into a spectrum analyzer, and then you can see a spectrum analysis of the frequencies that are not notched out, because the way the AA501 works is it auto finds the fundamental, notches out the fundamental, and assumes everything else is distortion and noise. So you can take a look and see what's coming out of that, and you could even put a 200 volt AC signal in, get some useful data out with a spectrum analyzer using the AA501 as a front end, and not grenade the spectrum analyzer. You put 200 volts peak to peak in front of a spectrum analyzer, and I don't know any of them that would actually survive that until you get into some very expensive power quality measurements and dedicated, like, high energy industrial power stuff. So kind of some neat ways to come at the waveform measurements and see what's going on. So I'm just let this run for a while, make sure there's no problems. And the unit is drawing 88 watts. So that's not terrible. I expect that to get a little bit better once we get C13 and C14 replaced. But I'm waiting on a bit of parts. So through the magic of the camera, you guys won't have to, but I will have to wait on the delivery guy. Okay, I've got the power supply hooked up. Well, I've got the power supply rebuilt, and I've got everything hooked back up and bolted down. Getting the new caps in and avoiding this inductor, this 8 Henry giant inductor, that was a trick. There's not really a good way to do that without one of those multi-section can caps on the top. One of these. So we had to improvise. The way it was wired was it comes off the diodes into a 10 microfarad cap, goes into the inductor, then goes into two 10 microfarad caps that are in parallel, and then it goes into the 47 microfarad cap. Now the main problem that I had is this particular unit is tube based, which means it has a warm up time, and I measured the power supply because I thought I'd be able to do this and not wait for the shipping guy. The problem was, unloaded, the power supply in this unit is about 465 volts at 123 volts mains. So way over a 460 or a 450 volt cap. So it would have gotten cranky. So I had to order 500 volt caps. I used extra long life electrolytics. Now on this one, because the power supply switching frequency is kind of low, ESR is always a concern, but it's not the ultimate concern on this one because this is switching at 60 hertz. It's mains transformer. And then the 47 microfarad, nope, not that one. These guys. This is the 47 microfarad, 500 volts. He's hiding right there. I had to add 3 tie points to get all these connections made because there's stuff spiderwebbing everywhere coming off of these caps. So I have the meters hooked up so I can monitor the power rails. I'm going to turn this on now. Nothing's going to happen due to the fact that I don't have any power applied. It's at 0 volts. And I don't want to volt slam these caps either because they're running pretty close to their rating. We'll just wind this up a little bit. And see, that's about 40 volts AC. It's about 150 volts B plus at the moment. Nothing's going to warm up yet. But we're drawing current, but not excessive current. So let's keep going. It's about 250 volts B plus. We're at 65 volts. It should be also noted that this is not advised, bringing something up slowly like this on a with a switching power supply. Switching power supplies really don't like being undervolted. So this is a linear supply, so we can do this without hurting anything. That's 124 volts on the variac. We are current limiting out, which is fine, but it does look like we're starting. Let's see if I actually get some waveforms out of this. We're not overcurrenting, but we are drawing a decent amount of current. Oh yeah, I've got waveforms. So let's give it full line voltage right now. We're at 121, which is fine. We'll bump up a little bit more. Put it at 123, because that's what the lab kind of tends to run at. Now I'm seeing a little harmonic distortion in there, and we're running at about a negative 47 THD. Not horrible, but because we have all brand new caps, the balancing is probably off. So this does need to be aligned. I'm thinking I'm going to go after these two caps. I'm going to let the power supply run for a while, just see what kind of numbers this thing puts up, and also make sure the power supply is not going to burn down on me. But right now what I want to do is I want to turn the tubes off and show you guys some of the reasons for the weirdness. Okay, as we look at the meters, keep in mind this is the highest voltage across the cap, because this is before the inductor, after the inductor, and the 47 microfarad after the second pair of capacitors. So this is first 10 microfarads, 20 microfarads, because it's two 10s in parallel, 47 microfarad cap, and we're looking at the voltages across the caps. Tube should be cooled off by now, and I'm going to flip the switch now. So right there, 465, 464, 451. Now as the tubes warm up and come in, they were warm, so that's going to come in fast. But you'll see this voltage start to cruise down. This is plenty healthy for a 450 volt capacitor, but we have to get past that surge voltage before the tubes come in. This one too, 400, that 500 volt cap will run at 400 all day long. But a 450 volt cap, at least a modern one, would not survive that surge voltage for very long. So that was my concern with the capacitors. So now that we've seen that, I'm going to move this over to the mains electric. We're still going to monitor the current draw and everything like that. And actually our current draw is down. It was drawing about 90 watts. Now it's drawing about 81. So we dropped about 10 watts replacing the caps. So there was some stuff going on there. I'm going to disconnect the meter. I'm going to disconnect these meters right here. And then I'm going to move from the isolation transformer over to the mains, unisolated supply, and then I'm just going to let it cruise. I am going to monitor it on the PM100 for a while just to make sure it doesn't go crazy with the current draw, and we will see what happens. If we do end up not having problems, we'll let it burn in. I'll clean up the dial faces because I want to get the power supply rebuilt first. Clean up the dial faces, do the servicing on the switches and everything like that. And then we'll go through an alignment. And now that we're on the mains with a ground reference, part of our problem was some common mode noise. And what I saw in the scope is gone. And instead of negative 40, 49, we're at 54. Actually, negative 54 is specification for this unit. So this is actually now performing in specification and working, although it's falling a little bit, which is fine, but that means it's within adjustment range. So after a quick tweaking of the balances and things like that, we should come up pretty good. So I'm going to let this burn, and we're going to go from there. But it is a nice and stable sine wave. Here, I'll move over to the scope. Again, input monitor. So this is monitoring what's coming in from the... This is monitoring the front end of here. The nice thing about this is you can use an AA501 as an attenuator and shoot it out. Luna, this is an open piece of vacuum tube gear. I do not want you sniffing the 500 volts. Thank you. The lab cat says hello. And here's what the sine wave looks like on the scope. Very nice. This is running at 51.7 at the moment, so we'll definitely let it run. But as you can see, very stable on the Rigel. Well, I have given the unit a bath, both electrically and physically. Looks really good. I managed to get whatever that stuff was that was caked on the frequency wheel. I did put a layer of oil, light layer of oil on the frequency wheel just to keep it from corroding. Lubricated all the controls, got everything all set up, cleaned all the dust out, and fired it back up to let it run for the rest of the night. And I'm getting a negative 58.4 dB total harmonic distortion. So just with a bath, this thing got really gained 5 dB. Now, part of that could be because there was a nice layer of dust built up over the tubes. Thermally, they'll stabilize a lot at a lower temperature, so that could very well affect the characteristics. But, yeah, I'm just going to let it run, see how it goes. At this point, as long as nothing exciting happens, the restoration portion is done. I still need to do an alignment, but we'll get into that very shortly. But I have it set to 1 kilohertz of signal at 100% output, and I am getting negative 58.3 dB of THD out of this oscillator. So really happy with its performance and looking forward to seeing how it does after an alignment. Oh, for those that don't think about dB or distortion in dB, negative 58 dB is 0.123% THD. So still very good, especially for a unit as old as this. Okay, I'm starting the calibration procedure of the 200D. I am going to press into service an AA501A quite a bit for this calibration procedure. I know that's a tech piece of gear that's going to calibrate an HP piece of gear, but it's what I got and what we're going to run with. This is going to really need an AC voltmeter, and I need to reference dBs and a couple of other things through the service manual. And this is right smack in the middle of the AA501's wheelhouse, so it is the best tool for the job. I have a decade resistor box set to 600 ohms because I'm going to need a 600 ohm load for quite a bit of this. 12 volts, which is what we need at 600 ohms, is about 20 milliamps of current. And this particular decade resistor box, 80 milliamps of current on the higher resistance scale. So we are fine for current loading. We'll just hook this up. And if we take a look at the we're at 11.99, which is fine. If a control needed to be adjusted, it would be this potentiometer right here for the output of the unit. Now what I need to do is I need to play with the front controls of the distortion analyzer. But I will move you guys up here. And all I'm going to do on the 200 CD is turn the amplitude down. So what we want to do is we want to set dB ratio, and we want to set a 0. Now I want to turn the amplitude knob all the way down, and that should give me I need a reading above negative 46. We are at negative 53. So we are good to go there. Okay, now we need to play around with some frequency.
measurements where we're probably going to tune the capacitor. But what I need to do is get a BNC to banana, and then we will run this over to the frequency counter. Turn this back to AC volts. Okay, I have the oscilloscope coming out this end and then this end going into the frequency counter. I'm still leveraging the AA501 because I don't want to put 9 volts into the front end of my frequency counter because it has damage at 5, so the input can't take it. So we're using just the AA501 as a front end. Okay, we are off slightly, so we want to adjust C6, which is the front cap on the tuning gang. C3 is the one behind it. So we need to tweak that a bit, but I'm going to need a very low capacitive tuning tool. They also advise adjusting the capacitors slightly low because adding the case will tweak it just a bit. What we need to do here is C6. We are at 600. I'm going to need to crack that loose with something other than a tuning tool. She's a bit tight. There we go. Okay, C7's adjustment is not well marked in the manual, but it is right here. And that is done to put 600, is it 600 kilohertz on frequency? Yeah, 600 kilohertz. Did I have a multiplier wrong? Something seems not right. Okay, for the manuals, less than clear here. C17's adjustment is not for 600 kilocycles. It's not for 600 cycles. It's for 600 kilocycles. So the multiplier needs to be all the way up at the 10K, and then you adjust this capacitor for 600 exactly, or 600K exactly. Okay, I have 2 last adjustments I need to do. I need to adjust the dynamic balance for the least amount of distortion at 1 kilohertz, and I have to adjust the hum balance for the least amount of distortion on the 1x range. So we're going to do that with the AA501 here real quick. All right, at 1 kilohertz, 0.105 is about as good as I can get it, 1049, which gives us negative 59.5 dB. Spec is negative 54, so very happy about that. Now it's time to do the 1x range. Well, it turns out I had a speed problem in the lab. The AA501 does not like dealing with 60 hertz and the real low-end slow signals, so it was kind of struggling a little bit. I adjusted the hum balance with the FFT on the Rigol as best as I could. I'm going to look into getting something in the lab that can deal with extra slow signals. I've got a lot of stuff that deals with fast stuff pretty good, but now it seems I'm lacking on the slow side. But for now, this guy's ready for the bench. Thanks for stopping by the lab and taking a look at the restoration on this 200 CD. As normal with the Dish of Shame, we have a couple capacitors that were ready to be changed out to give this thing a nice lease on life for the long run. This is going to find a home right over there, and this is actually going to be a signal generator that I use on the bench quite often when I just need to throw signals onto something, especially having a nice big dial face is going to be a lot nicer than working on those tiny TM FGs. So really looking forward to putting this to good use. And as always, more is always on the way, and I will see everybody in the comments and the next video. Bye for now.